Welcome to this lesson. In this lesson, we're going to talk about the sine function in a as a summary from the function's perspective. Okay, from the function perspective. Number one is that we know the definition of function, right? So we have the rule. Okay, this rule of ours for sine is that it takes angles or arc lengths as input. It produces a ratio that's described in this entire stage set, We have worked out the domain and range, right? And it is a function, and we even work out the curves, right? So this is the function. Well, does it pass the vertical line test? It certainly does, right? If you draw vertical line arbitrarily, and you're gonna cross the curve exactly once. No, not less than once, because it will always touch the curve somewhere, because the domain for sine is all real numbers. So any vertical line you draw, you're gonna cross the curve exactly once. So the domain of definition, the definitional function is satisfied. Secondly, okay, if we recall the several concepts we talked about before, right? Before we get into any functions, and we start, in the first few weeks, we talk about these concepts, right? So after function, right, we talk about one-to-one function, right? What is one-to-one function? What is one-to-one function? One-to-one function, so from the one-to-one functions definition, we want to see is sine function one-to-one, okay? And of course, we know the horizontal line test. If we do the horizontal line, of course, it's not going to pass it, okay? So from the definition of one-to-one function, what can we say, right? Simple, short narrative to tell the reader it is not a one-to-one function, okay? Using the definition of one-to-one function. Therefore, we're going to review what is a one-to-one function. One-to-one function is a function f, right? The output for input x1 is not the same as the output for input x2 whenever input x1 is not the same as input x2. Okay, in our case, it is contrary to it, right? We also have learned what is not one-to-one, right? Not one-to-one. Not one-to-one is saying, well, not equal becomes equal. The opposite of one-to-one, the output will be equal whenever turned into for some. For some different inputs, the outputs are the same, right? So for that, we can easily make our case. For example, there's so many examples, right? We can say, quoting that example, right? We can say sine pi over 6 is the same as sine 5 pi over 6. 5 pi over 6. 5 pi over 6. Okay, period. The reader can clearly see the inputs are different, but the output are the same. From the unit circle, from that unit circle, we see that for these two angles, right, we only need one pair as a matter of fact, right? For input pi over 6, right? And the other input, which is 5 pi over 6, for these two inputs, their output for sine function are the same, which is half, right? You don't even have to mention half. You don't have even to mention half. If you want to, no problem, go ahead. Okay, so this is one perspective, right? You can see it from the unit circles perspective. And the other one, we can simply use this curve we worked out, right? We can simply use this curve we worked out. Horizontal line test, right? So for example, I can draw a horizontal line. Okay, what horizontal line do you think I can draw? You can really draw anything, right? You can really draw any horizontal line between -1 and +1 to make that case, right? So another way to say it, because there's so many examples, right? Another way, right? We can use this graph. We can use a graph, okay? Draw a horizontal line. For example, I'm going to draw this horizontal line, which is half, right? Half. I'm going to draw, let's see, what color do we want to use? Maybe yellow, maybe green, a light green, with maybe a broken line. Okay, it crosses, right? What does this tell us? This tells us for this particular output half, we have how many inputs corresponds to it? We have input here, which is pi over 6, 5 pi over 6, right? We have even more. We actually have more. Do we need more? Do we need to use more? No, we don't need to use more. So to make the case it's not 1-to-1, we really just need one pair that make this happen. And we already found it, right? So for the narrative, this picture, you can also make this case, right? Are there other examples? Of course, there's just so many of them, right? Suppose if I draw the horizontal line of, instead of half, what if I'm using horizontal line equals to, how about just 1, right? 1, simple and easy, right? See, we have output equals to 1. How many inputs for it, right? There's so many examples. So you can use these 2 points. So this is also related to how to use the curve we have produced, we have produced, right? Now we get this point, that point. So we can, as long as we can identify these points, and then now we can say sine pi over 2, right? We do the easy one first. Is the same as sine. What is this out? What is this input? This input, I think, is negative 3 pi over 4. That's 3 pi over 2, sorry, 3 pi over 2. Okay, so once again, different input, same output. So all of these are different ways of saying that sine is not a 1-to-1 function. This is not a 1-to-1 function to make our case, And at this point, I also want to encourage you to use the decimals, okay, to use decimals. Okay, so I'm going to bring the decimal curve with us, right? So let me bring it here and share that with you, okay? Once you learn how to use decimals, you can work, and you know how to work it, right? You have to know how to work it. Once you know how to work it, you can use it to demonstrate a lot of things. Okay, so this is decimals. Okay. Let's see, I need to, all right, so I'm gonna bring this down and bring this guy up, okay? And just 1 second, I'll be right with you on this picture, okay? So here we're going to share both pictures. Does that work? Do we see both pictures? I hope so. I hope we do. Do we see both pictures? No, let's see it again. Okay, stop share and share screen. There, it works. Okay. So suppose we use the curved decimals, right? Decimals can afford us a lot of things. For example, the examples we used earlier to make the case it's not a one-to-one, right? You just draw a horizontal line arbitrarily. Okay, of course, you want to hit the curve, you have to draw that horizontal line between -1 to +1. I have this curve, you know, the good thing about this curve, it marks the, it could mark radians very easily on the, you know, on the horizontal direction. It can also mark them on the vertical direction if you want it, okay, in the future. So in this case, we can just draw a horizontal line, right? And this horizontal line I'm going to draw, it can be, you know, whoops, okay, it can be square root 2 over 2, right? So this line is going to be crossing, wait, where is it? Let's see. Okay, there you go, the horizontal line, okay? So this is a horizontal line. So I basically draw this horizontal line, right? Because to make the case that the function is not one-to-one, all you have to say is just you do the horizontal line test, and horizontal line test, they give us the guideline to find the different input that produces the same output, right? So in this case, we actually got 2 points, 3 points, more points. We have many, many points, right? Let's see if we can identify these points. If we can identify these points, okay? To identify these points, I also want to bring you the unit circle, right? A lot of us like to use the unit circle, so I certainly would encourage you guys to do that, right? I would encourage you guys to do that. So here's the unit circle, right? So when I draw this horizontal line, right? And the line is root 2 over 2, that means the outputs are root 2 over 2. So what are these points? Root 2 over 2, you can find this is root 2 over 2 here, this number, root 2 over 2, another root 2 over 2. So you have already identified these 2 points on a unit circle. So that will help. And of course, there are many, many different answers, right? You can if you use the angle measurement, you can have so many answers. So these are pi over 4, comma, root 2 over 2, right? So that's 1 point, right? And we can have it marked, it's labeled. And next point, we can mark the next point, which is we can do it 3 pi over 4, okay? 3 pi over 4, right? Comma, square root of 2 over 2. There you go, right? So now we have 2 different inputs, same output. The output are both root 2 over 2. And so this case, whether it's from the narrative to visual, it should be very simple and straightforward, and everybody needs to be able to speak the sentence and make your case. Okay, same output for different inputs. Okay, so now we made the case for sine is not one-to-one function. Okay, so next, what was the next concept we like to talk about? Increasing, decreasing. Okay, increasing function, decreasing function. What is the increasing function? What's the decreasing function? Right? Sine function apparently is neither increasing nor decreasing, but it increases sometimes and decreases some other times. So how do we speak that language, right? How do we speak that language? This requires us to identify the points, okay? So here I'm gonna clean up this graph we just did, right? So I'm gonna clean up the graph. And how we're gonna make that narrative, right? How do we make that narrative to identify these points? Okay, so in order to make that narrative, we have to identify the points, right? We did a graph from -2 pi to 0 and 0 to 2 pi, right? You see only from this piece, you can see the up and downs, right? So sine function apparently is neither increasing nor decreasing in its domain. Okay, so let's make that statement. Sine function is neither increasing nor decreasing in its domain, which is all real numbers, Okay, so that's not a question. The problem is we learn to speak the language that one is increases and one is decreases. Okay, for that, we're going to review the definition of increasing function. Increasing function definition. What's the definition of increasing function? The increasing function definition. Okay, it's kind of similar to one-to-one. Okay, so I'm going to copy this here and just to show you what has changed. Okay, increasing function will have, okay, whenever the input x1 is less than input x2 and their respective outputs, f of x1 will be less than f of x2. Decreasing function, okay, decreasing function, we still have the whenever the same. We still have the whenever the same. The only thing that changed is that instead of less than, f of xy less than, oops, okay, this should be x sub 2, okay, instead of less than, okay, and this is going to be reversing that relationship, reversed. You see, this way, hopefully it will help you to kind of understand, right? Kind of understand. So let's recapture what it means on this graph, right? What it means on this graph. So now this is the picture. This is a picture of sine curve. Suppose I only show you from -2 pi to +2 pi. Okay, so let me see if I can make it just a little bit larger. Oops, -2 pi. From this interval, right? From 0 to 2 pi, from 0 to 2 pi, you can see this is 0 and this goes up. So in this interval between 0 to pi over 2 is increasing. If I just extend a little bit, right? From -pi over 2 to +pi over 2 on this interval. Okay, on this interval, I use the gold color. Okay, remember why I use the gold color? Because the horizontal represent the radians or the arc lengths, right? So on this interval, sine is increasing. Sine is increasing because whenever x1 is less than x2, f of x1 is less than f of x2. That is true. That is true. For input, say input here, there's input here, there's input there, and their respective output, okay? Their respective output is this relationship. So the output for x2 is always larger than the other one, and when this input is less than the other one. But anyway, it works Okay, now let's look at the description. Let's look at the description. How do we describe it? How do we describe it, right? How do we describe it? So here are some examples of how to describe it. We can say sine, okay, is increasing in the interval of negative pi over 2 to pi over 2. Okay, so from negative pi over 2, which is this piece of interval. This piece over here, not too thick, right? So this piece is increasing. Okay, so how about the next piece? The next piece is decreasing. Okay, the next piece is decreasing. So I can say sine x. Okay, you can use whatever a or whatever, right? Is decreasing. And we must indicate the variable. We must indicate the interval at which the function is increasing or decreasing. If we don't indicate the interval, then that statement will be wrong. Okay, so whenever we say a certain function is increasing or decreasing, if we don't indicate the interval, by default, it will refer to the domain. And if on that domain, the function is not increasing and not decreasing, then you have made a false statement. So we always have to say when a function is increasing where, a function is decreasing where. This is especially important as you move on to your next course, okay? Your future courses, especially those calculus classes. So sine x is decreasing from pi over 2, okay, from pi over 2 to 3 pi over 2. 3 pi over 2. There. Okay, so the next one would be where it's decreasing will be this piece. It's decreasing. Okay, so in this box, sine curve is decreasing. So increasing, decreasing. Between increasing and decreasing, there's a transition point. And that point, in this case, is the highest point in this local area. And of course, this is also one of the highest point on this, on the domain of sine. You're going to learn about this. They will be called like maximum, minimum, right? Those are called extreme values. And you can follow these examples to do a lot of things, right? To make your statement. And that's part of the narrative. That's part of our narrative. Okay, so increasing, decreasing, so you can continue this process. You can continue this process. Now, to summarize, right? So when we say something, when we say a function, right? When we say a function is increasing or decreasing, we must indicate where it is increasing and where it is decreasing. And the interval that in that description is part of the domain. If it is a whole domain, such as exponential function e to the power x is increasing, you can just say, hey, e to the power x is increasing. You actually don't need to say much more. Okay, so for example, e to the power x, okay, is an increasing function. You did not specify the where. Well, that by default will be considered this function is an increasing function in the entire domain for f of x equals to e to the power x. However, if you make a wrong statement, okay, then it will be judged false. Okay, but anyway, so these are the what can be said, right? What can be said about this function. The next one is the even odd function. We talk about even odd function for sine, okay? And we use this concept, right? Sine function is even or odd. Sine function is odd. How do we know it's odd? Wait, whoopsie. Sorry, this guy, come back. Okay, odd. Okay, sine function is odd function. Well, we have to know what is even function, what is odd function, right? So even function, odd function. Odd function, even function usually refer to the entire domain or a specified interval. Okay, sometimes we do use specified interval for that even odd function. Then we will specify the domain. Okay, we'll specify the domain. Because the way even function, odd function is defined, right? Even function is defined as that for input, right? Opposite input produces the same output. That's even function. Okay. How about odd function? Odd function is that the opposite input, okay, the opposite output, right? I'm sorry, opposite input, but their output are opposite. So this guy is equals to the negative of it. Okay, so that's odd function. Odd function. Okay, so now sine is odd. How do we know sine is odd? Right? And these x's we have to specify these x are in the entire domain by default. Okay, unless otherwise specified. Okay, in domain. Okay, and this other one is also in domain. And of course, we need to understand that for opposite inputs, right, they both must be in the domain. So you can see it usually include positive number and negative number. Right? For example, natural log x, ln x, is neither even nor odd because its domain is positive number. It doesn't include negative number. So you cannot even express ln -2. Therefore, it cannot be even nor odd. A sine function is defined on the entire number line. So if we look at some examples of its evenness, of its, whether it's even or odd, which you already seen it, right, from the unit circle. So let's look at the graph, right? If this is, I'm going to use arbitrary. I'm not going to use special value here, okay? I'm going to use arbitrary value. Input, you see, I deliberately not landing on the special angles, okay? And that's the opposite of the input. So this, if this is x, and that's negative x, negative x. And what's their output? Their output, okay, we're going to be consistent with ourselves, which is the blue. And the blue. On your homework, you saw lots of examples, right? For you to see that it's odd function. So this is f of x. So this piece is f of x sine, let me write it, sine x, right? And this other piece, because sine x, this is for input x. And so the other piece is sine of negative x. Okay, they are opposite to each other. Opposite to each other means that if I put a negative sign, if I flip over one of the blue over the x-axis, we will get exactly the other one. Okay, so if I flip this sine x over, I will get the next piece, okay, which will be under the x-axis. So this piece, okay, we're going to call it negative of sine x. So sine x is an odd function. Sine x is an odd function, right? And this is true for any input. This is true for any input. On your homework, okay, on your homework, the intention is for you to study the unit circle, study the sine curve, and see it for yourself. Okay, so next I'm going to bring back your homework. No, actually, how about you look at your homework? Okay, I'm going to look at the unit circle for you. Okay, I'm going to look at that unit circle for you. Right? How do we look at the oddness of this function, right? So I'm going to put this away. I'm going to make less space for the picture. Okay, so let me just move down a little bit. Okay, over here, right? And this other picture, the unit circle here, and we probably don't need this one. Okay, let's not using, I think I have a better picture over there. There, that's fine. Okay. In fact, I really just want to use this unit circle, okay, because we talked about the curve already. But I put this here to remind you we've done this, right? We've done this. Okay. So now, if you look at the unit circle, right, on your homework, right, I intentionally giving you like sine pi over 6, sine of negative pi over 6 for you to observe, right? And you can see sine of pi over 6, right? Pi over 6 is measured from standard position. This is a terminal, right? Negative pi over 6 will be measured from the standard position and clockwise. And the opposite input, right? Opposite angles, 30 degree, negative 30 degree. Opposite arc length, okay, opposite arc length. What are the ratios? The ratios, half and negative half, they're opposite. You see, opposite input, opposite output. So on the picture, so we really just, we're trying to enhance these ideas of using the ARD, period, right? Pi over 6. Okay, I should make that thicker. Okay, pi over 6, right? Over here, pi over 6, negative pi over 6, right? And the positive half over here, and the negative half over there. Whenever inputs are opposite, the output are opposite as well. You can see that is true for all the special angles on sine, right? So how do you draw this? How do you draw those angles, right? How do you draw those angles? And this is what we do, right? if for other pairs, right? I certainly give you other pairs. Suppose I'm going to draw an angle terminates, right? At this is 3 pi over 4, right? Positive, counterclockwise. Negative, 3 pi over 4, right? And the blue numbers, the inputs are opposites, right? Positive 3 pi over 4, negative 3 pi over 4. And the ratio are root 2 over 2 and negative root 2 over 2. Okay, I apologize. This may not be very clear to you, but you've seen this table. You've seen this table, okay? But anyway, so this is how you see the odd function for real, and it has a physical presence. It has meanings, and the meanings are all concentrated on the fundamental definitions of function. Okay, it's all about input, output, input, output. So this is the summary that I wish to do it with you. And of course, once we have these narratives, we have these perspectives, right? And we see sine function from all the perspectives we talk about. Function, one-to-one, yes or no, right? Increasing, decreasing, even, odd, right? All of these questions, all of these concepts are discussed in the process. And that is actually the primary reason when I have chosen the homework questions for you, because I want you to observe those observe the unit circle in different way and observe the curve in certain way, so you can see that consistency. You can see that consistency. Okay, so once again, let's close this lesson by going back to see the definition one more time. A function is a rule. So sine function is a rule that assign each input, which is an angle, produces exactly one output, which is a ratio. And the domain and range for sine, what is it? Right here, right here, okay? You can specify A, or you don't have to specify A. In most of the cases, people would specify A. They would say for angle, right, radian or degree, anything, to be any real number. So this is domain range in one sentence, okay? Let's see, what else I should cover. I think I have covered pretty much everything from for our functions perspective. If you have any specific questions, okay, if you have any specific questions, please don't hesitate to reach out to me. So this study hopefully give you some kind of guideline. So this is also laying a model for the study of cosine, tangent, cotangent, etc., etc. When we are studying cosine, we actually will also follow these blueprints. Okay, function, right? Is it function? Is it one-to-one? Is it increasing? Is it decreasing? Is it even? Is it odd? Okay, that's all we do. For tangent, we do the same thing. And of course, in the future, we'll add the period, because we know this is a periodic function, right? Sine is a periodic function. What is per period? 2 pi, right? 2 pi, which is one round, going around the circle once, right? So 2 pi, one cycle, another cycle 2 pi. So sine function as a periodic function, its period is 2 pi, okay? So these are the contents pretty much we study, and we study just following that guideline. And meanwhile, we very much focus on the centerpiece of these trig functions. Okay, standard position, A, right, angle measurement, reference angle definition. This is our centerpiece, absolute centerpiece. Okay, absolute centerpiece. And we understand that the input are angles or arc lengths or degrees, can be anything. The outputs are ratios. And for the 6 trig functions, there are ratios of various kind. Okay, it's just x, y, r in different order. Okay, x, y, r in different order. You pick 2 numbers out of x, y, r. Okay, x, y, r. You pick any 2 numbers and you make a new ratio. That's what we do. That's what we do. Okay, so without further ado, and I think this lesson, hopefully it's helpful for us to understand, have an overall pictures from the functions perspective for sine. And if you have any questions, please don't hesitate to reach out to me, and so I can make more recordings for you to help our understanding of the subject matter. Okay, so thank you for watching.